So following on from some of the earlier videos, we got to a stage where we can represent Taylor series as this summation. So now we need to check for convergence. So to check for convergence, we're going to use the ratio test. So when it comes to the ratio test, we always need to get an plus 1 divided by an. This is your an plus 1. Divided by an is the same as multiplying by the reciprocal of an, which will be this. So now simplify this. So if you look at this thing here and this thing, you've got minus 1 to the power whatever, minus 1 to the power whatever. If you merge them together, these two will either be 1 or will be negative 1 or 1, be negative 1 or 1. But then when you take the absolute of the whole thing, it doesn't matter if it's negative 1 or 1. It was, well, you can just discard these two boxes straight away. Okay, so that will then take us to here. And then now let me think. Now rewrite this as rewrite it as x minus 1 times x minus 1 to the power of n, and then x minus 1 to the power of 1, which will be this. Okay, so now bear with me. Now this block will cancel out with this block, so that will then take you to here. Group all the n's together, so that will then give you this, and then you've got this. So remember, for convergence, we require this thing here to be less than 1. So we require this thing here to be less than 1. Well, as n tends to infinity, this thing here is going to head towards 1. So for convergence, we just require the absolute of this. We just require the absolute of this to be less than 1 for convergence. So now, once you're here, translate it to this, and then now add 1 to everything. So that will then take you to here. So what we know so far is that anything strictly greater than 0 and strictly less than 2, we know definitely for sure that that's the red line. That the red line will map on top of the blue line as n heads towards infinity. We will know that it will converge. So we will know that this red line here will definitely map on top of this blue line in this interval. Okay, so now we need to check the endpoints. We now need to check the endpoints. So to check the endpoints at x equals 0, put 0 into here. So 0 take away 1, that will then give you negative 1. And then now tidy this up. Hang on, let me think. Yeah, so now tidy this up. So here you've got exactly the same. So you can just get these two and add them together. So that will then give you so hang on, exactly the same. So that will be this, and then basically get this, add this. So that will then give you 2n plus 1. That will then give you, so this would then become 2n plus 1. Well, 2n plus 1 is an odd number. So minus 1 to the power of an odd number, that will always be minus 1. So now take, so this minus 1's a constant, so take it out. That will then give you this. So we've seen this before. This is a harmonic series, and we know that as n heads to infinity, this thing here will diverge. It will diverge. And here, even though it's a negative, we can't say the whole thing here diverges. We've seen this in the past. You should by now recognize the minute you see this whole thing here, you should be able to tell that it's going to diverge. We've seen this many times. Okay, so dead on 0. We know it's going to diverge. So now we need to check what happens when it's dead on 2. So at x equals 2, so going back to the original series, at x equals 2, we would put 2 into here. So now 2 take away 1, that will be 1. So 1 to the power of n will be 1. So we can just ignore this block. That will then give us this. So remember, and again, you should be able to tell that this is going to converge, because 1 over n, we know is the summation as n tends to infinity. We know it's going to diverge. But if you have if you have an alternating harmonic series, which is what this is, it's going to converge. We've seen this many times, and you should recognize that this is going to converge. So this is going to converge. So what that means is this. What that means is we know for sure that anything in between we know definitely for sure that this is going to map on top of this. Dead on 0 is going to diverge. Dead on 2 we know is going to converge. So the domain for our series would be this, would be strictly greater than 0, including the number 2. So this is your domain here. Okay, so anything in here, anything in this interval, we know that this will definitely map on top of this as n heads towards infinity. Okay.